Thank you. Appreciate it. Komið sæl. Hi there. I'm Thor. I'm from Reykjavik, Iceland. I'm a co-founder at a company called Sólfar, and we are developing VR games and experiences. What I'm going to talk about today is a few kind of early lessons that we've learned from building Believable VR, building believable worlds that drive immersion and presence, and some of the lessons that we've learned from our development across the multiple VR platforms. Just a couple of words about us. We're a VR studio, started a year ago in Iceland. We're ex-CCP Games guys, so worked on development of EVE Online back in the day. But we're a pure play, very focused developer and publisher doing exclusively VR games and experiences, and we're really setting out to do something hopefully quite special in the first few years of this amazing space. We're also super happy today to announce here at Slush that we have completed our seed series financing. So we just announced this morning that we've raised 2 million euros from a great group of investors, including two great home VCs here in Finland, InVenture and Reactor Ventures, in addition to NSA Ventures from Iceland and Shanda Group from China. So I'm going to start with a video. This is one of our first projects in development. This is something that we announced together with Sony at E3 last June, and it's a project called Godling, and I'll talk a little bit about some of the things we've learned along the way. Please play the video.
Welcome back, little Godling.
So Godling is a VR adventure game. It's a game that is basically putting you in the shoes of a tiny toddler god, really miniature god. So we're playing with scale and size within the VR design environment, where you can grow and nurture your world, basically help the creatures achieve success and the world to grow, or else you can actually do some bad things, like actually burn it straight to the ground. So it's a sandbox adventure game. It plays off some of our design strengths from what we learned creating EVE Online back in the day. But it's also been a project where we've learned some of the first lessons from our first year developing VR content. And we've distilled this into kind of a set of 4 design pillars. And this is sort of the core design principles that we follow at Sólfar when we're looking at how we approach a project and whether it kind of ticks these 4 boxes for us as a project. And these are effectively immersion, exploration, agency, and social. So the first one seems like an obvious point, but we believe fully that really to achieve suspension of disbelief in VR, meaning that you really believe that you're in the simulation, we really need to get AAA quality graphics. So very high quality, high frame rate graphics that give you that sense of really being in the environment. And the problem is that VR performance requirements are incredibly intense. You need to run variously at 90 frames a second or 60 frames a second, or even faster, to actually achieve full frame rate and achieve comfort in the simulation. So this is a critical hurdle that we think is something that some developers are finding quite difficult to make work for them. But we do believe firmly that you need to take some of the tips and tricks from the sort of AAA console and PC games industry and apply those to creating something that really gives you that deep sense of being in the simulation. The second one is really about a sense of exploration. So the strange thing about VR is that it gives us this amazing immersive world, but much of the VR content that we see today is created in such a way that you actually have less exploration, less control, and how you navigate through the world than you do in a 2D conventional video game. So VR gives with one hand and takes away with the other. And so this is really a critical point as you're thinking about developing games and experiences for VR. What is your navigation model? How are you actually allowing people to move through the space? John Carmack talked about this at Oculus Connect, where the first-person viewpoint gives the highest sense of immersion, but it's also the type of navigation model that is most conducive to motion sickness. So this is a real challenge when you're creating content for VR. And so many developers have tended to shy away from allowing you to navigate the world, to open the door, to see what's on the other side. And we firmly believe that we have to, as game developers and content developers, solve for this problem. So one of the things that we've done in Godling, we've been iterating the game. We started out as a first-person experience. We've actually shifted now into a hybrid mode, basically a third-person mode that allows you to look down on your character, navigate comfortably through the scene, and then snap into first-person view and get that high immersion experience that first-person delivers so well. So this is really a key aspect of what we think really matters in terms of allowing VR to really take the potential that it really has. It has to be a truly immersive experience that allows you to explore the world around you. The next thing that really matters is player agency. And again, as a video game developer, you kind of think, well, this is kind of obvious. But to make the world believable, it actually has to allow you to interact and control and change what happens in the world. It can't be a passive sit back and watch experience. This probably dates me, but when I think about spherical 360 video in VR, I have one word for that: QuickTime VR. This is a type of passive viewing experience that does not really deliver the sense of presence that we firmly believe VR needs. So it has to be designed in a modern game engine like Unreal 4, and you have to allow the player to actually have a sense of agency and control of the world around them. And the final one really is the social aspect. So sharing an experience with another person is always more emotionally rewarding than playing against the computer. We certainly learned this at CCP, creating EVE Online, and this is the type of game design that we're applying to our projects, thinking about how we can create a simulation where at least 2 players are together, and hopefully more over time. And we think that that really is something that is going to make virtual reality shine, and we've certainly seen some great examples, like from Oculus with their Toy Box demo, that proves that this is really the sweet spot in terms of game design for VR. So I'm going to show you our next project, just a first look at something that we announced here at Slush as well. If we could play video, please.
She has many names. To some, she is Sakamata, the goddess of the sky. To others, she is the apex experience, awe-inspiring, unforgiving, the pinnacle of human achievement. We know her as Everest.
So Everest VR is a project that we also announced here at Slush. It's a co-development between our company Sólfar and RVX, the visual effects and animation studio, also based in Iceland, just down the road from us. And we're working together to create what we think is quite a special experience. It's really allowing you in first person, viscerally, to experience what it feels like to climb Mount Everest. And so these are some shots just from Unreal 4 showing some of the visual fidelity, again, the sense of immersion and AAA graphics that we feel are going to be critical to driving success in VR. So these are actual shots from Unreal showing you the level of detail that we're achieving in the simulation itself. And this is Lhotse, one of the peaks, and of course, that is Mount Everest in CGI. This asset was actually created by RVX using a technique called stereophotogrammetry. So they worked from a database of 300,000 high-resolution images and then used GPU acceleration from NVIDIA to actually create a 3D point cloud, then the mesh itself, and then apply the photographs to create the textures that you're seeing here applied to the mesh itself. Just to show you a quick behind-the-scenes look at how complex this is. So this is, sorry, if I go back one, if we can play the video next, please. So what you're looking at here is just a brief kind of, tech porn video, basically. It shows us basically the complexity of the scene. So we're actually using 126 patches. Each of those patches is 8K texture resolution. And this is what we're actually delivering and doing at full frame rate in VR today. 90 frames a second on HTC Vive. We actually have this running in a demo suite here at Slush. If you guys are interested in taking a look, I would encourage you to go after the talk to the Reactor Ventures stand. They're over there. And they actually have some sign-up slots if you actually want to climb Mount Everest with us tomorrow. So again, go to Reactor Ventures, and they'll get you hooked up. Thank you very much. Great to be here. Kitos.